Hello and welcome to my video, lesson 8.5, modeling data with sinusoidal functions. So here we have a table of values, and it gives the height of a pendulum above the ground as a function of time. So what does that mean, really? Well, there's a point up top where the pendulum is attached, and looks like at the 0th time, it is hanging at some height. Right? Maybe we'll do it like this. Okay, so that's the ground, and it's hanging at some sort of height. Maybe, oops, from here to here, some sort of height, which in our case is 15 centimeters. Okay, it's not going to be exactly correct, but it looks like at time 0 it is at 15 centimeters, and then after half a second it gets part way. After like somewhat around 1 second, maybe it gets to about here, maybe a little bit lower. Okay, and then after 2 seconds, it gets back to the same height, but over here. So this is maybe something around 8.1 centimeters, and this is something around the 15 centimeters. So you can imagine that it's just swinging back and forth, like this, up, and then back. All right, so with that in mind, we need to find an equation for this, and then maybe we can answer question, perhaps something. Oh, that didn't do what I wanted. Perhaps a question like find the amount of time spent above 12 centimeters during the first 10 seconds. All right, so we're going to try to answer that question in a moment. First, we're going to plug all this data into our calculator. So stat, edit, okay, edit here, and then we just enter. We plug in all of our data into L1 and L2. Then what we do is we click stat, calc, and then we go down until we see the sine regression right there. Press enter, go down to store, vars, y vars, which just means variables, y variables function, y1. So that's storing it in the y equals y1 spot. So it's now right over here. Okay, and this is where it's important that you are in radians, not degrees, otherwise this will not work. But there is our graph. It's not perfectly meeting up with our data points, but that's actually kind of the point where our regression gets an average, and so maybe our measurements weren't perfect. Okay, now, oh, and what you want to do also, zoom 9 gets you to that exact window size. Now, the only thing we want to do differently is start at time 0 and end at time 10 seconds. Because that is what this question is asking. Actually, we might want to make it a little bit shorter. Let's make it 9 seconds. So let's make our window 9 seconds, and let's change the wording of this question here during the first 9 seconds, just to make it a Math 30-2 level question. Okay, so what we're going to do here is, since we, it is starting a little bit early. That's okay. Since we want to know what time it spent above 12 centimeters, if we go to Y2, we can make that a line that goes across, cutting off at 12 centimeters. All right, which allows us to find some intersects. So let's do that right now. Second function, calc intersect. Okay, so that first intersect is 1.5649. You could record more, but that's probably fine. Second calc intersect, and now we're going to find the next intersect spot, which is right about here. Guess, and so it says to 2.38465. Okay, so this is the length of time it spent above 12 centimeters during this sort of curve, right? And then it's just 4 of them. So let's figure this out first. There's actually 4.5 because this first part is exactly 1/2. So 2.38465 minus 1.5649 equals, so I'm going to do this in the calculator here. So x minus 1.5649. So the x, it just stored it from my latest calculation of x, which is the x-intercept. So this gives me 0.81975. And then, like I said before, we have 4.5 curves during that period of time. So we just need to multiply by 4.5. So this equals 3.68889. So let's just round that up to 3.7 seconds. All right, so I hope this video helps you understand how to model sinusoidal data. It's just using regression analysis, and then we can start using our graphs to get information from it. All right, I hope this video helps, and good luck.